Hey guys, welcome to Programming Knowledge. In the previous video, we have seen what STL actually is, what all it contains, and other stuff, right? So, from this video onwards, we are going to focus on implementing the contents of STL, implementing the classes which we get with STL to increase our productivity, right? And more importantly, in this video, we are going to discuss about vectors to the core. And the reason why I picked vectors is because we already are familiar with it, and you actually get an idea of how vectors actually work to the core in this video, because it's actually easier for you to catch up, right? So let's just begin with it. So I'll just begin by including the vector class. What's happening to my spellings? Vector, right? And I can actually create a vector class. So vector int v, right? So this is basically a vector which can hold integer type objects. Now what is a vector? Vector is nothing but a dynamic array, that's it. So what is happening here is that, so if you see how we deal with an array in C++ or even C, what you do here is that you just say that, right? So int a of 10, so it's basically 10, it's basically a space which can contain 10 integers, which is basically 40 bytes of continuous memory. That's what you're requesting to the computer or the operating system when you say this statement, right? But what a vector does is it doesn't know how many elements you want it to store. So basically, whenever it gets a new element, it's going to create a new array for that, and I'm going to prove that exact thing to you. So what I'm going to do here is, instead of int, I'm just going to create a custom class, let's say C over here, right? So class C, and I'll just say public. I'll just create a constructor which will just say object has been created. So this is basically for visualization of how it actually works. So if I just say object created, right, and then I just do destructor, right? I just create destructor, and I just say cout object destroyed /n, right? Now I have a small class which is basically empty, it doesn't do anything, but the important point here is that it notifies you whenever an object has been created or destroyed. So what I'm going to do here is create 4 objects, A, B, C and D, and if I run this code, well, the output is not surprising. You will be seeing that 4 objects have been created and 4 objects have been destroyed, right? So now what I'm going to do here is I'm going to make things more exciting. What I'm going to do here is that I'm going to push back these elements. So if I just do v dot pushback A, v dot pushback B, right, v dot pushback C, and then v dot pushback D. I did that and I run the code. Well, it's the previous code. I need to build and run this, and now you see I have 4 objects created, but then these many objects get destroyed, right? Why is that? I did not even create the object, but then vector somehow is creating new objects. Now why is that happening? That's happening because when you start with vector like this, the capacity of this vector is actually 1. It can only hold 1 element of this class C, right? So whatever you put here, if you put a int, it can hold only 1 integer. If you put float, it can hold only 1 float, right? And the other things are going to get dynamically occupied on the heap. Now you have your memory gets partitioned. I did not talk about this, I know, but then I'll just give a quick overview of that. But what you have when you run your program is, well, your memory is split into different portions, and what we as programmers are interested in are the stack and heap. So stack is basically where all your variables which are part of your script or your part of your instructions, because all these are basically instructions to the CPU, right? So if you open the assembly, you will just find instructions. So all the variables which are involved in that instructions are actually stored in the stack. So if I just say vector v, the actual position of v is in the stack, right? And then if I just say int a or even the C, A, B, C, D, so these 4 objects are on the stack. But then what happens inside is, whenever the program needs extra memory during the runtime, right? Because well, I created 5 objects, but maybe during the runtime it had to create another 6th object, but then it doesn't have it did not request the CPU for that much memory, so it's going to request the CPU during runtime for some extra memory. So CPU is just going to allocate some memory from the heap, and it's going to store everything there. So that is what heap is, and this is extremely slow. Well, it's not technically extremely slow, it's not as slow as you think, but then compared to the stack, it's really slow. So that is why whenever you code, make sure that you put all your variables inside the stack. Well, you try at least to put all your variables inside the stack, right? Because stack is not really big. But if it's required, try to minimize the usage of heap, but then if it's required, well, you can't help it but use the heap, right? So that's about it. But why I'm talking about this thing over here is, whenever I push back, an extra array is being created on the heap, and then all these elements are being copied there. So I can prove that to you if I just keep a copy constructor over here. So if I just do const c other, right, and I can just put a statement over here that this has been copied, right? So object copied, and now if I run the code, well, let me just remove this, I'll just comment this thing out and run this. You see, every time 4 objects have been created, that's fine, and then A has been copied inside the position, right? A has been copied inside the vector. Now B has to be copied, but then there is no space, since I told you that vector starts out with 1 capacity. So it's going to copy A, copy B, and then destroy the location where A was there. And that's what is happening now. So again, I want to copy C, I don't have space, so I create a new space. A, B, C are copied, A and B are destroyed. Again, I want to copy D, so this time only 1 copy has been done. That's because vector doesn't actually it doesn't increase space one by one. It has an algorithm which can increase space depending on the size of the current vector, right? Well, that's another story, but then it's not exactly 1 by 1. That's why you're just seeing that D has been directly copied inside. But in case there's a need, then, well, the bottom line is that in case there's a need, you are copying objects, which is bad, right? So that's the point. Now you want to reduce this. How can you do that? Well, whenever you're using an array, you kind of know what the size of array is going to be, right? So you can at least estimate the size of the array, right? Size of array or vector or whatever it is. So what you can do is reserve that much space, right? So if I just say reserve, so what this is going to do here is, if I pass in some number, say n, which is this thing, size type n, it's going to reserve that much space inside the memory. So this copying is reduced. So now if I just do, let's say 10, let's say I expect 10 elements, but then I just store 4, it's okay, right? But then if I expect 10 and I store 20, then only 10 elements are getting copied, but effectively, right? So that's a kind of underlying assumptions you need to make while using vectors, because they are storing objects, and copying objects is really bad, because here, well, this class doesn't have anything. It's literally the size of this class is 1 byte, right? And that's also not required, because that 1 byte is used just because I am defining this class, right? So there's no variable inside this, it doesn't hold anything. It's just a class, it's just some template which doesn't do anything. That's why it's just 1 byte. But then if you have a class which does something and then it has some heavy parameters, then it's really bad when you're copying objects like this every single time, right? So it's going to be a serious performance hit on your program, and you want to reduce that, and that's why you reserve some space so that copying is actually reduced. Now if I run this, I'd be getting only 4 copies, right? So 4 items created, 4 items copied, 8 items destroyed, right? And technically you cannot pass references. Well, you think that the copying can be stopped by passing references, but you cannot pass references because references exist only for existing variables, right? So you need to create extra variables then, but that's useless, right? So it's as good as copying, right? So it's not really good, it's not really predictive. But then what you can do is what some people do this, right? What they do here is that they store pointers. Now why pointers? Because a pointer is just an address, it's just a number, right? So copying a number, it's not at all cost effective, it's just flipping the bits, right? So copying a number is that simple. So what happens here is that people just store the pointers inside the vector and then store the actual object somewhere else, so maybe in a linked list or something like that, right? And then they access the pointer and then point to the location where the object actually is. So that's also actually a good practice, I should say, but that's highly debatable. People say that I should keep items, the objects inside the vector, but then some people argue that keeping pointers is more effective. But then it's up to you, you can use it however you want. But if you are going to use directly the objects inside the vector, then do reserve the space, because if you are not going to reserve the space, it's going to be a huge performance impact on your program. So that's about using vectors as a storage container. I think I spoke a bit long about this thing, but then it has to be addressed. And if you are learning C++, it means that you want the performance, right? So it's really important that you know about this, what pushback does. But then there are other functions too, but I'm not sure how they actually work in other compilers, because I'm not really used to this MinGW compiler, right? I use MSVC, the Microsoft Visual Studio compiler, and then from C++ 11 they have a function called mPlaceback instead of pushback. So when you push back, you actually create another object and then push it back. So it's basically you're creating a new object. But then when you mPlaceback, what you do here is that you actually take the existing object and then push it inside the vector. So that's actually happening. But then I don't know, but in this particular compiler, which is the MinGW, right, it doesn't mPlaceback correctly. Well, as much as I know, it doesn't replace back correctly, right? It's just working just like pushback. I tried it before. So if you want to try it, it's just available after C++ 11. So you need to go to your compiler and then check one of the flags. So it's C++ 11 or 14, right? So you need to check one of them. But then in MSVC, it works as expected. So when you mPlaceback, it doesn't create a new object, but then it mPlaces it puts the original objects inside the vector, right? So that's about mPlaceback. You could try it out, but maybe I'm wrong, right? So if you know that, correct me. But then that's about pushing back and then storing items inside the vector, and other things are kind of simpler. So now let's just go and talk about the constructor of vector. So if I just do vector v, I have a constructor, so I can just create existing object. I can start the vector with some objects. So let's say I want to start with 3 integers, I can just do that, and the default is 0. If you want some other integer, you can just do that. So if I just put comma -1, it means that I'm starting with 3 elements with -1. The difference between reserve and this thing is that it starts out with that much, well, it already has 3 elements, but then when I reserve space, it doesn't have any element, but it has the capacity to store those many elements. So that's the difference, right? So that's about the constructor. If you do that, what you're basically saying is that I want 3 elements, each of them are -1, right? And you can also directly assign it, so you are implicitly converting it to a vector. That's also possible. I could just do 1 2 3. Well, let me just do something like -1 5 4 0 and 9, right? So you'll understand why I'm doing this in a second. So I could just do that. That's also possible. And now coming to iterators, now I just completed containers. Well, let's go in order. So what I just completed is the container part of vector. Now coming to the algorithmic part, right? I'll just include an algorithm header file. So I'll just say #include algorithm, right? And what I can do with algorithm is that I can search, find, sort, and all these things. So I'll just show you sort and then find, right? But then you can do lots of things with the algorithm header file, right? There are literally functions for almost all the algorithmic things you need for dealing with the data, right? So for sorting, it's really simple. I just need to sort. From where I need to sort from the beginning. Now this begin and end are actually iterators, and we'll talk about what iterators are. But I already told you in the previous video that you can think of iterators as pointers. So it's more or less the same. So you can just say that it's the pointer to the beginning of the vector, and if I do v.end, it's basically pointed to the end of the vector. It's not the last element, it is the end. So it's basically one after the last element. and then I want to sort all these things in the ascending order, so default is ascending, right? And I can just show the elements of this vector. So please excuse me for now, I'm just going to use the for each loop. I'll explain what it does in another video, but then you can just write down your normal for loop if you want to, if you don't understand what this is, but it's fine, right? It's just going to print out the elements. So yeah, I'll just say cout I and then put a space and then put a new line over there. And now if I run this, I'll be getting -1 0 4 5 9, which is basically sorted order of this vector, right? And now if I want to sort it in descending order, I have few options. What I can do here is I can just say greater int, right? And then this. Now what it's going to do here is that it's just going to send the greater elements to the first. It's basically going to say which one of them is greater, and then it's going to sort it accordingly. So now if I run this, I'll be getting the list sorted in, vector sorted in the descending order. Now if this is confusing, what you can do here is that you can define your own function. It doesn't really matter, and that's what you're going to do if you're going to sort vectors of classes or vectors of structures, something like that. Well, vectors of structures, you cannot sort them in ascending or descending order unless you say how to sort them, right? So the how is what this parameter is, and I can create a function to do that. So if I can just create a boolean, let's say larger, right? So which one is larger? I'll just take two integers, int a, int b, because that's what my type of object is. So it's an integer, and what I'm going to do here is I'm just going to return if a is greater than b or not. If it is, right, if a is greater than b, it's going to be in the beginning of the list. If it's not, it's going to be at the end of the list. And then it uses some algorithm, right? So you're searching algorithms, but then it's going to use a very specific algorithm for sorting, and you don't have to worry about that unless you're a beginner. It's highly optimized, and it's going to sort your list in no time. So I think it's n log n time, right? So if you know the complexity, so that's the time complexity of this algorithm, and space is I think 1, right? So I'm not really sure about that. So what you need to do here is that you need to send in this particular function as a function pointer. Now I know I haven't spoken about function pointers yet, but then you can think of function pointers as just the name of the function. That's it, right? Don't call the function, you don't do that. This is basically calling the function, but you're just passing which function to call. So I'm just saying that call this larger function every time. So I do that, run this code, I'll be getting the sorted array over here. And now if I want to sort it in ascending order, I will just reverse the sign. So if a is less than b, it's going to be at the beginning, or else it's going to be at the end. If I just run this, I'll be getting it in the ascending order, right? So that's how you sort vectors, and then you can find vectors. Find items inside the vector. So what I'm going to do here is I'm just going to say find, and then from the beginning till where do I want to find? I want to find till the end. And what do I want to find? I want to find whether this is 0 or not. So if I do that, and this is going to return me an iterator, it's going to return me the position, right? So it's going to return me, you can think of it as a vector pointer, right? It's going to return me that. So it's basically this thing, vector int iterator, and let's say it, right? So if you don't want to write this whole name, you can just replace it with this thing, auto. That's what it does. Auto, it basically what it does is it guesses the type for you, it types the type for you, right? So don't just plug in auto everywhere. I shouldn't be using this is actually a bad practice. If you write bigger code, you'll find it harder to debug, but then it's fine because it's just one single page of code, right? So it's fine. If I just do that, and now what I can do here is I can just compare it. So if it is not equal to v.n, because if I don't find the item, I'm going to be at the end, right? If I'm not at the end, it means I have found the item. So I can just say that cout item found, and you already have the iterator to that point, so it's fine. Or else what you can do here is that say that item has not been found, so cout item not found, right? And then I'll just put this new line over here, right? and if I run this, you will be seeing that I have found the item because 0 exists. So if I just do something like 100 which doesn't exist and then run the code again, yeah, run the code again, you see that item has not been found because the iterator has moved to the end of the position, end of the vector I should say, right? So that's about finding, and you have lots of other things. You have find if not, and all those things. I'll leave it to you to explore. STD algorithm is really useful, and searching, sorting, and all these things are actually very common tasks you will be doing when you are actually programming a solution, right? So that's about algorithm. And then iterators, I actually talked about iterators over here, so this is what iterators are, but then you can also use it as a way to actually look through the vector. So that's what they are. So as I told you, iterators are nothing but, you can just think of them as pointers. They are nothing but pointers, I should say, right? So what you can do here is that you can just do something like vector int iterator, and then again, if you don't want to type this whole thing, just put auto vector iterator it equal to, I'm just going to start from the beginning, and v.begin, v.end, all these are going to return iterators. They are going to return pointers. Okay, so v.begin, and then it is not equal to v.end, so till I don't reach the end, and then I can just increment this iterator, and I can just use it just like a pointer. So I could just do star it to get the value at that particular location. So I'm sure you're familiar with pointers, so that's how you can do it, right? And here I could just put a new line to separate that debug output which code blocks generate, and if I do that, I can see my vector, so -15409. So it's just like a pointer, right? And pointers are really useful, iterators are really useful, and it's out of practice that you understand how to work with pointers. But because in the beginning it just seemed useless, right? Even I felt pointers are really useless, but then over time they do make a lot of sense. So pointers are really helpful. So that's about everything vectors can do. And then, well, I only talked about insertion. Well, there's a deletion thing as well. What you can do is v.popback, it's going to remove the last element. And now if I just show you that, right, so auto I in v, I can just print out I, right, and then just run this code. I'll be getting -1540. The 9 has been removed, right? And then if you want to erase something, you can erase it with your iterator, right? It again needs a pointer to the location where you want to erase. So let's say I want to erase 4. So how I can do that is, I can just say v.begin plus the index. So index of 4 is basically, it's 0, 1, 2, right? So I can just say +2, right? So 0, if I just v.begin, it's basically this thing, +1 is this, +2 is this. So I can just do that. And now if I just run this, you won't be seeing 4 there, right? So -1, 5, 0 and 9, 4 has been deleted. And then if I want to delete a range of elements, that's also possible. So let's say I want to delete from 5 to 0. So I can just say v.begin +1. And then for 0, what I can do here is, I could just say v.begin plus, what is that, 0, 1, 2, 3, right? I could do v.begin +3, or I could do is -1. So v.end -1 is also 0. So I could do that, and either way, if I just run this, I'll be getting the same output, which is -1 and 9. All these things have been erased. So that's about erase. And then if you want to clear the entire vector, what you can do here is just say clear, right? What it does is, it completely removes every single item inside your vector. And then if I just run this, you will be seeing that nothing exists inside the vector. So that's all about vectors. And now coming to the point of when to use it and when not to use it. Whenever you want to access elements in random, right? So let me just put it in bold. No, use vectors whenever you want to access elements frequently. This is really important. If you are not going to access elements frequently, don't use a vector, right? Let me just stress on this point. Why am I telling you this? The reason is because vectors act like arrays, right? So vectors are more or less like arrays. They are continuous blocks of memory, but then every single time you are adding an element, you are effectively creating a new memory location, right? And then you're copying stuff and then deleting stuff. That's really bad. You shouldn't be doing that. You should be avoiding doing that, right? So what we need to do here is, whenever we need a array like structure, when do we need array like structure? When we want to actually access random elements. If I want to just access the fifth element or the fourth element, or randomly access the second element, when I'm doing such things, I do need a array, right? I cannot use something like a list, because as I told you in one of the previous videos, list, if you want to access nth element of a list, you need to travel from the beginning to the nth element, right? But in case of an array, you already know the starting position, you know the size, you add the size to the starting position, you get to the point where you need it, right? So it's just like that. So if I want to get till 0, what I can do here is just say v dot begin, this is the starting position, plus 3, right? That's 0 for me, right? So it's just simple as that. That is why you generally tend to use vectors or arrays or whatever whenever you want to access elements more frequently. If you want to store elements more frequently, if you think that you will be adding and deleting elements very frequently, then you should use list, not vectors, and list is going to be the topic for the next video. So be sure to check it out. But then the bottom line is that use vectors whenever you want to access elements frequently, and how you can reduce the performance hit is by using reserve or tricks like that. So that's about vectors. There's actually a lot more things to vectors which you can actually browse and find out, but these are the things which are really important for you to know. And in the next video we are going to explore lists. So till then, happy coding.